3.3 Algebra 2, Semester 2, simplifying rational expressions. So we're going to start with a little review, and we are going to work on simplifying just plain old fractions, reducing fractions. So what we would do is you would get all the factors of 8. So you have 1 and 8, 2 and 4. Right, so these are all the factors of 8. And then 40 would have 1 and 40, 2 and 20, 3, no, 4 and 10, and then 5 and 8. 8, 10, 20, sorry, 40. All right, and now we're going to look for the big, I know that's kind of sloppy and I apologize. It's not as responsive on this Mac, so I apologize. We'll bear with it, not a big deal. So I get all the factors. So 1 times 8 is 8, 2 times 4 is 8, 1 times 40, 2 times 20, 4 times 10, and 5 times 8 all give me 40. So what I'm going to look for is I'm going to look for the biggest number that they have in common, which is going to be an 8. So I know this is going to be 1 times 8 on top. Now on the bottom is going to be 5 times 8. All right, and then what we see is that the 8s can cancel. And I reduce this fraction down to 1/5. So I simplify that fraction just by finding the factors. All right, I'm going to do the same thing over here. Is you're going to have 1 and 6, 2 and 3. We'll figure this pen out eventually. All right, then we're going to have 1 and 39. 2 isn't going to work. 3 and 13. 3 and 13. 4, I don't think it's going to work. 5, I think that might be it. Just kind of go with it. 18 and 39. I believe that's all the factors of it, but I'm just kind of spitballing here. So again, find the biggest number. In this case is going to be 3 that these two have in common. So 6 is going to be 2 times 3 on top. And the bottom is going to be 3 times 13. Again, these numbers can cancel. Right, they're the same. So I'm left with 2 over 13. All right, I'm going to slide over here and do the same thing. Find the 35. And now I'm going to kind of spitball. I'm not going to draw it out. I'm going to do this part that I've been doing in red. I'm going to do it in my head. So I know that they're both going to have a 7 in common. If I take a 7 out of 35, I'm left with 5. So I divide 35 by 7, and I got 5. Then I'm going to divide 42 by 7, I'm going to get 6. So I can just reduce that 5, 6. I did the exact same thing I did over here, I just did it in my head. If you're able to do it in your head, you go right ahead. If not, go ahead and write it out. Both methods are perfectly fine. All right, now taking this on to the actual content that we're talking about. We're going to use the same concept, and we're going to apply it to rational expressions. So we want to write a rational expression that is equal to the following, which would be this. So we want to know what's equal to this when x does not equal 1 or -5. Now, let's explain this. We don't need to do anything with this. What this is doing is giving us the domain, excuse me. So 1 and -5, kind of like we just did at 1.2, where we were determining what would make the rational expression undefined. These are the values that would make the rational expression undefined. So they've already done that, and you're supposed to just write them there. That, hey, you can't have x equals 1 and you can't have x equals -5 because that would make these two 0 and make the entire thing undefined. So that's all that means. We don't need to worry about it. All right, so similar to what we just did on the last page with the fractions, I'm looking for what they have in common. Well, I can't cancel this x and that x. They're in parentheses, they're in binomials. We can't go and just cancel individual pieces because they're being added and subtracted. However, this is an x minus 1 and this is an x minus 1 top and bottom. I can cancel that. So this is a 4 over x plus 5. Boom, that's all this is. So 9, write a rational expression that is equal to the following rational expression. When x doesn't equal 3 or -5, again, that's just explaining what would make it undefined. And as far as us, we're going to see if anything has top and bottom. Boom, they both have an x plus 5. And I can simply just cancel those. I can finish that 9 and x minus 3. Now, what I cannot do, I can't cancel these two x's. I can't just swipe them out, right? There's an addition and subtraction sign, so we can't just swipe them. If it was multiplication, we could, which is how we were able to do this. I also can't divide this 9 and this 3. It doesn't work that way. Because these are connected by plus and minus signs, we have to leave them as is.